is
So,
what is this green strip
what you
right
see
down
there
here?
with this ribbon is it does fill in that gap, that small rip
In
out.
two previous images,
That's
we
why
could
we actually
see
see
that.
The oceanic crust. So what you really have is ocean.
Well,
that's literally
it's
been
not really a
squeezed
very active fault line.
out of
and it's
existence.
not very strong. So,
If you don't believe me on
look
that,
at the Rift Valley,
this
wait
is
10 million
extremely
years, and you'll see
A lot
that the
of
Mediterranean
vultures, a lot of
Sea
tearing,
no longer
pulling.
exists.
We just don't see that here in the center of the
How
shot.
you wait 10 million years.
We could. But I think one of the reasons why we don't is you do have a force from the Eurasian and the North American plate moving apart. So you have a force that's squeezing on this side. And then you also have the Pacific plate that, although it's sliding past California, that's a whole different type of plate boundary. It also is colliding from that direction. So it's actually really
there is no tectonic together.
And that's why we're not really
So by
seeing
taking the aids of the moon rocks, we can then get a better accurate.
Now there's one more chain of lakes
That's
that
not
you
how
guys
it
might
is.
not think of that much.
But
Great Lakes.
this does run us into problems when we're trying to find more.
How do the Great Lakes
evidence
form?
of early ages
Try
of
again.
Earth. Because a lot of that rock has been
Way before
recycled.
glacier.
It's already been destroyed, spit back out somewhere else.
The divergent
So
plate
that
boundaries.
does give us big challenges on trying to find good, solid evidence in a lot of places. I do this one red. So with your constant to constant, we do get the big mountain ranges. You guys see that line? So again, two examples. That is a divergent
Himalayan
plate
mountains?
that originally is what opened up
And
the lakes.
The Alps.
The glaciers. You guys think about this for a minute. I know everybody tells you the glaciers.
So
carved the
right
lakes.
here are two
Stop and
pictures.
think about this for a minute. Both of the Himalayas. It's not like Michigan was the only state that had glaciers in it. It covered the entire world. Why don't we find
And
these
you can
big
see
open valleys? This image right here,
continents
it's
somewhere
very it's well defined
all
how
those
steep that front edge of the Himalayan mountains
So
are.
it's not that they were formed by the glaciers, the holes
This
were already
really
there.
does
All the
create
glacier
some
did
famous mountain ranges
was
on
fill it
Earth.
in.
You know, 2 continents wide.
So
This
the
is
water,
like two semis.
these
These glaciers
glaciated
get
water.
wet.
So all they do,
But the valleys
They
that
force each
fill
other up.
were
Yeah.
there from
so the Alps
divergent plate mountains.
are actually pieces of the African plate. You guys ever heard
So
of the
yes.
Matterhorn?
As you asked, Brandy, the St.
Um,
Louis Seaway is another
actually,
example
we'll
of
get
a
to-
divergent
Actually,
plate boundary.
next
where the
Tuesday,
northern part of Canada
you guys
and
will
the
be watching a
States are
video
slowly
on the Alps.
opening up. And it's really kind of cool because it actually
Which
shows
that
how
could actually
part
explain
of
some of the
top
earthquakes that we had in
Matterhorn
Washington, D.C.
is actually rock
You
from
see
much
the
closer
African plate.
to this line than it is.
And yet it's somehow
to
stuck in the
the
middle of
fault.
Europe.
So that's where
So
the
those
two
are
places
some of the
come.
divergent plate boundaries. Okay, next one I want to talk
The
about.
last one I want to talk about is a transform boundary.
is convergent.
You know,
What does it mean to converge?
yeah, looks like. Join together, combine. That's exactly it.
So with a convergent boundary, we have two plates that are coming together.
What's happening in the transform boundary?
Go ahead. And we have three types of convergent plate boundaries. I'm going to show you images of each one of these three. So,
This is actually
divergent is pulling apart.
Convergent.
So the first one is ocean to ocean.
Transform. It's just a
What I want you guys to do is when
slide.
we take notes over this, I want you guys to look at the key. So
that's all that
transfer
transfer
boundary
boundary
is.
is.
Okay, so it's where we have the two plates that are
All
sliding past
convergent
one
boundaries
another.
are the same thing.
And most of these occur at the
Depending on
ocean
the types
ridges.
of plates,
We get different geologic features.
San Andreas is a perfect.
So in a normal convergent boundary,
San Andreas fault.
you
is
have
the
one
transform boundary between
piece
the
of cross
Pacific plate
that is
and the
subducted.
Yes.
But this right here is called the
Apart.
subduction zone. To be subducted means to get the
Pushed
LA San Diego area
Now, if you think about this,
Oceanic plate, the Pacific plate. Take your hand,
San Francisco,
throw them together, on the North American plate, and immediately you'll start feeling
so what you're going to have,
and then what starts to
at one point in time, you're going to have, say, April and LA are slightly moving to the northwest.
Okay, good.
Heat, pressure,
What
most
else?
of the United States
What
continental
feature?
is slightly to the southeast.
What am I actually making now?
So eventually, those three cities will be neighbors. So I'm getting an arch on this side for the one that's not getting subducted. What's getting forced between my two hands?
Like a ridge.
Not the ridge. So that's all that is.
Trench.
And usually, so you
When
can
it turns
see
from
the
mountain, you get
trench
very, very shallow earthquakes.
right here. So that's your trench. And just as you said, right, we get this arc
By shallow, we usually
coming up right here, right? And that's because all that stuff gets pushed up
deep
behind
ones are 20, 30 miles under
it.
the crust.
Sorry.
What? Now, I want to talk about why we get subduction. Fall through anything. Okay, that's pretty much it.
Can we get back to the thing?
We'll get back to that in a minute. Why would one plate get subducted underneath another?
Because one's heavier than the other.
What do you mean by heavier?
Like the plate that gets conducted weighs more, so it like starts. to
Not
hang
so
down.
much that it weighs more.
Side.
Not the size.
The shape.
Nope, not the shape.
The way it's
Let's talk about the type of material it's made out of.
oh, the
If you mix water with oil, what happens to the oil? The oil will find its way to the top. Why is that? Not lighter, not thicker. Give me a more scientific terminology than lighter. It's less what? There, it's less dense. There we go. So the denser plate gets pushed underneath the less dense plate, correct? Now, I'm not sure if you guys remember doing this, but remember we measured the density of granite rock and basalt rock? You guys remember doing that? Which one was more dense? No, basalt is more dense than granite. So if you think about that, remember your continental crusts are granitic, your oceanic crusts are basaltic, and therefore when they collide, the basalt becomes more dense, and therefore it gets pushed underneath. So it's all due to density. But now, I want you to notice something here. What do I have forming right here? What is this? They're volcanoes, yeah. And how do we know they're islands? Yeah, what's the difference between a volcano and an island?
Volcano is on a great mass land. An island is in the middle of the ocean.
There you go, it's surrounded by ocean water. So if I got an ocean crust colliding with another ocean crust, what I actually get then, and this is what it's really important for you guys to know, I get volcanic island chains.
Is that like the last
You can almost think of it as arcs of volcanic island chains. Yes, the Aleutian Islands are a perfect example of that. The Japanese islands, the Marianas Islands, the Philippine Islands, all these islands mimic the shape of the trench. They run parallel to the trench. So that's when we start getting all these volcanic islands along these trenches that encircle the entire Pacific coast.
so like those possibly become volcanoes.
Say that again?
So those possibly can become.
Well, those are actually volcanoes. But when we think about a volcano, we think about it as being on this big piece of continent, but most of them are actually formed with the ocean. So that's ocean. So again, we can look at right here, right, we have the Aleutian Island chains. Those are all volcanoes that are forced up from the ocean crust being subducted underneath. And we can see again, we have the island chains of the Japanese islands, all the way down through here to the Marianas, as well as the Philippines. These are all examples of plate tectonics taking place every single day. Okay, so that was ocean to ocean. Now let's talk about ocean continent. What's different? It looks exactly the same, but there's something different. It's a continent. Good. So, all right. So this side over here is definitely a continent. It's above water. Go ahead.
It's not considered islands anymore.
It's not. There's definitely volcanoes, though.
Well, it's because like there wasn't anything to the right of the island before the
So what do we call these?
volcano.
Let's say you're driving along, and then you see this. What would you start calling those? Starts with an M. Mountains. There we go. So when you have ocean and continent, you don't get volcanic island chains. Instead, we get volcanic mountain chains.
So like the continents are making up the islands pretty much.
Say that again.
So like the landmass is like
Oh, the island chain or the volcanoes form because as this is being subducted, there's so much heat from the friction that the rock starts to melt, and therefore becomes less dense than the surrounding. So actually, all that magma gets pushed up to the surface, which then even then increases the amount of ripples that we start to see. Therefore, we see the volcanoes form.
But I'm talking about like the side of the mountain there.
This side here.
Yes.
No, this is all the original continental crust. Okay. So again, take your fingers and you run them together. This hand over here is going to start crumpling up. Because it's still moving, but as soon as it hits that ocean plate, you get friction, and that keeps it from easily sliding forward. So you get all this backup from behind it. Okay, it's like having several people walking in a line. Probably did this a lot in elementary school. They make you guys like the chain gang walk down the hallway. If that front person stops abruptly, what happens? Everybody piles up behind them. It's the same concept right here. When this front edge stops abruptly, what happens to all the material behind it? Piles up behind. So a lot of times your mountain chains are another way of identifying where we have convergent plate boundaries.
So is that how Hawaii was formed? then?
No. Why is a whole other issue. So, these form volcanic mountain chains or volcanic arcs. Okay. So we're going to see that here in this image. And then you can see where, as that's being subducted, the heat forces the magma upward, creating the volcanoes. Okay. Some examples of these are like the Andes Mountains, the Cascade Range. You have the Rocky Mountains through British Columbia, all the way up through Alaska. You have the Brooks Range. All these are major volcanic chains. The Alps are another example of these. Yes. I'm having to think on that one. But I would say yes. Well, they are mountains. They're very old. They're a lot older than the Rocky Mountains. And the reason why we know that is they've been eroded that much. That's how we know how old they are. They're a lot older than the Rocky Mountains. They just look a lot smaller because they've just been eroded away. But yes, I would say that's definitely an example of that. Okay, the last one I want to talk about is continent to continent. And I did misspeak on this. The Alps is not an example of ocean to continent. The Alps are continent to continent. Now, one of the things I want to make sure we point out is that now we have two types of crust. We have a continent and a continent coming together. So what I want you to notice